Hello, my dear bachos, and welcome back. I know, exams are just around the corner and Chapter 1 can feel a little heavy. But don't you worry, your Ravi sir is here and we're going to make this chapter super simple and completely stress-free. Let's get you ready to score full marks.
Namaste, bachon. See, chemistry isn't some scary monster. It's actually really fascinating. In this quick explainer, we're going to hit all the important points from this chapter. Just give me your focus for the next few minutes, and I promise you're going to feel so much more confident. So, are you ready? Let's begin.
So what is chemistry, really? I think this quote says it all. It's the science of the tiny building blocks of everything you see around you. The chair you're on, the water you drink, even the air you're breathing right now. It's all about these little particles called molecules and how they change and play with each other. Okay, so to really get chemistry, we have to start with the absolute basic. And that, my dear students, is matter. We're going to break down what it is, its different forms, and trust me, it's way simpler than you think. Just look around you for a second. Your NCERT textbook? It has some weight, right? It has mass, and it takes up space on your table. That is matter. What about the air in your room? You can't see it, but it definitely has mass, and it fills the entire space. That's also matter. The key thing to remember is this. If it has mass and it occupies space, it's matter. Simple. Now, matter can exist in different forms, or as we call them, states. In a solid, like, say, an ice cube, the particles are packed super tightly, kind of like students in a very disciplined assembly line. In a liquid, like water, they're still close, but they can slide past each other. And in a gas, like steam, they're just all over the place, far apart and flying around freely. Okay, now we can divide all matter into two big families, pure substances and mixtures. A pure substance has a fixed recipe, a fixed composition, like a school uniform. Water, for example, will always be H2O. But a mixture is like your school bag. Its composition can change. You can put 2 books or 5, just like with Nimbu Pani. Some people like more sugar, some like less. Now, mixtures themselves have 2 types. A homogeneous mixture is uniform all the way through. When you mix sugar and milk, can you see the sugar particles afterwards? Nope. But in a heterogeneous mixture, like your favorite bale puri, you can clearly see all the different parts. The sev, the murmura, the onions. See? It's so easy to remember with food. And let's go back to our pure substances family for a second. They can be either elements or compounds. An element is the purest of the pure. It's made of only one kind of atom. A copper wire is only made of copper atoms, nothing else. But a compound is when 2 or more different atoms join hands in a fixed, permanent friendship. Like in water, 2 hydrogen atoms and 1 oxygen atom are always together in that fixed 2:1 ratio. All right, bachcho, take a deep breath. We are now entering the most important section of this chapter, the mole concept. I know, this topic can seem a little scary, but trust your Ravi sir, we will make it so easy, you'll be solving numericals with total confidence. I mean, just think about it. Atoms are so incredibly tiny, you can't see them. If I give you a glass of water, can you even imagine trying to count the number of H2O molecules inside? It's impossible. So chemists needed a clever way to count these tiny particles. And that's where our superhero, the mole, comes into the picture. Please, don't get confused by the name mole. It is just a word for a number, a counting unit. That's all. Just like we say 1 dozen when we want 12 bananas, or 1 century for 100 runs in cricket. In chemistry, when we say 1 mole, we just mean a specific number of atoms or molecules. It's simply a counting number for chemists. And what is that magic number? It's this one right here, 6.022 times 10 to the power of 23. This is the famous Avogadro's number. And let me tell you, it's a mind-bogglingly large number. To give you an idea, if you had 1 mole of rupees, you could spend 1 lakh crore rupees every single second for millions of years. That's how big it is. Okay, so how does this giant number help us? We can't count individual atoms, but we can weigh things on a scale. This is where molar mass comes in. It is simply the mass of 1 mole of anything. And here's the best part. The mass of 1 single molecule in you, that's atomic mass units, is numerically the exact same as the mass of 1 mole of that substance in grams. The number stays the same, we just change the unit. So convenient. Let's see this in action with a classic exam question. Calculating the molecular mass of glucose. The formula is C6H12O6. So, as you see on the slide, we have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. We just multiply the number of each atom by its atomic mass, and then we add it all up. The result is 180.162 U. And because of what we just learned, this also means the molar mass of glucose is 180.162 grams per mole. See? Simple.
Excellent work. We've learned about matter, we know how to count atoms. Now let's look at the simple rules that all chemical reactions have to follow. Think of these as the traffic rules of chemistry. Every single reaction has to obey them.
The first and most important rule is the law of conservation of mass. It's super simple. It just means you can't create matter out of thin air, and you can't destroy it either. Whatever mass you start with in the beginning, you must end up with the exact same total mass at the end. It's like baking. If you start with 1 kilogram of ingredients for a cake, the final cake will also weigh 1 kilogram. The second rule is the law of definite proportions. This means a compound always has the same elements in the same proportion by mass. It's like a fixed recipe that never, ever changes. Water, whether you get it from a river in Kerala or from a glacier in the Himalayas, will always be H2O. Its composition is fixed. All right, you have been learning wonderfully. So now, let's put that knowledge to the test, shall we? It is time for a rapid-fire quiz with some very important questions that often pop up in your exams. Let's see how you do. Okay, here's a very common 2-mark question. I want you to just take a second and think. What is the main difference between an empirical formula and a molecular formula? This one is a favorite of the paper setters.
And here's the answer. Think of the molecular formula as the full name. It shows you the exact number of atoms in a molecule. The empirical formula is more like a nickname. It's just the simplest whole number ratio. So in our example, the full name is C2H4Cl2. If we divide everything by 2, we get the simplest ratio, CH2Cl, which is its nickname, its empirical formula.
Okay, next question. A little bit of math. If you have 36 grams of water, how many moles of water is that? I've even given you a hint on the slide. The molar mass of water is about 18 grams per mole. Come on, you can do this one.
And the answer is 2 moles. Fantastic! As you can see, the formula is so simple. Moles equals given mass divided by molar mass. So we just do 36 grams divided by 18 grams per mole, and that gives us 2 moles. Excellent work! And just like that, we're at the end. We've covered matter, states of matter, mixtures, pure substances, the mighty mole concept, and the basic laws of chemistry. You have revised all the really crucial concepts from this chapter. You are so much more prepared now.
My dear students, remember to just stay calm and be confident. You have worked hard and you know this stuff. Go into that exam hall and give it your absolute best shot. You've got this. All the very best for your exams from your Ravi sir.